Today we're going to talk about Unit 4, which is probability. It's a really short unit. It's 3 very short lessons, but there are quite a bit of notes in this, so while you are watching this, feel free to pause the video anytime you need to catch up on the notes. Make sure you have your notebook and pencil out then. So the first thing we have is just the probability itself. What is probability? Probability is the chance of something happening. And we have this scale here of impossible up to certain. So if something is impossible, that's got a 0% chance of happening, and meaning it's never ever going to happen. On the opposite end, we have it's certain that it's going to happen, meaning all the time it's going to happen. In the middle, we have 50%, which is just as likely to happen as not to happen. And then if something's less than that, like 25%, it's unlikely, or somewhere around the neighborhood of 75%, it's more likely. So let's do some examples. What is the likelihood of getting into a car accident? Now, it's not 0%, but it's also not 100%. It's probably not even 50%. It's probably right here where it's more unlikely. Not that it's never going to happen, but it could. Same thing with winning the lottery. It is very unlikely that it's going to happen, but it could. Flipping a coin. Well, you got heads and you have tails. That's 50-50, so that is equally likely to happen. Rolling 2 dice and getting a 7. Well, if you go through and figure out all the ways to get a 7, it's quite a bit. Because remember, you're rolling 2 dice, so it could be all of these possibilities. So this is very likely. It's not 100%, but it is likely. Finding a 4-leaf clover. Again, kind of like winning the lottery. It's not ever going to happen, but it's very unlikely to happen. 70% chance of rain, that kind of falls in here, which means it would be likely. Rolling 1 die and getting an 8. Well, there's only 1 through 6 on a die, so it's never going to happen. There are 7 days in a week. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. 1, 2, 3, 4, 5, 6, 7. Yep, that is certain. There is 7 days in a week. So the next word we have is outcomes. The outcomes are the expected results of an experiment. Okay, so example, you had 10 outcomes to rolling the die, not 10. Rolling a die, you only have 6. My fault. 6 outcomes of rolling a dice, 2 outcomes of flipping a coin. Flipping a coin, it's heads and tails. Rolling a dice, 1, 2, 3, 4, 5, 6. Those are the expected outcomes of an experiment. So, theoretical probability is what we're going to talk about now. Probability based on facts and mathematics. So the number of favorable outcomes, this is what you want out of the possible outcomes. Okay, so for example, rolling a dice. Rolling a dice example, sorry, that's where I got this. Rolling a dice and rolling a 6. There's only 1 6 out of 6 sides. So your probability is 1/6. Rolling an even number. There's 2, 4, and 6 out of the 6 sides. So that's 3 out of 6, or if we simplify, 1/2. So let's look at this spinner and see what our theoretical probabilities are. Remember, it is what we want out of the total possible, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. So our bottom number is going to be 8 because we have 8 possibilities. How about spinning a 5 and a 6? Well, here's the 5, here's the 6. That's 2 out of the 8. Simplify it down to 1/4, okay? Not spinning a 1 or a 2. All 8. I don't want 1 or 2, which leaves me with 1, 2, 3, 4, 5, 6. Let's try that again. 1, 2, 3, 4, 5, 6. Yep. Sorry, keep hitting another button. 6 eighths. Again, simplify that down to 3 fourths. How about spinning less than a 3? So again, 8 possible, less than a 3. Well, there's 2 and 1 that are less than a 3. So that's only 2 possibilities. Simplify that down to 1 fourth. I'm going to keep erasing this stuff off of the spinner so that we can see the spinner. How about rolling a 10 or spinning a 10? There are no 10s on here, so that's 0. 0 out of 8. One more time, out of 8. Spinning a 4 or a 7. Well, here's our 4, here's our 7. That's 2 possibilities. Simplify it down to 1 fourth. Again, 8 possibilities. How about spinning a 4 and a 7? Well, if we're only spinning it once, we can't do both, so we call that 0. Here we had an or, so you could spin one or the other. On letter F, they want an and you can't do both. So we're already into lesson 4.2. Now we're going to talk about experimental data. Experimental probability, I'm sorry. Probability is based on the results of an experiment. So the number of times the wanted event occurred over the total number of trials. Okay, so again, this is different. This is what we wanted over the number of times we did the experiment. Okay, so let's take a look at some examples here. Apparently I'm missing letters A and B, not sure where they are. C, here's letter C, this is split in 2 here. Spinning a 3. Well, their 3 is 1 fourth of this. So if we split it into 1 fourth, we have a total of 4 possibilities, and that is 1 fourth. How about not spinning a 2 or a 3? So I don't want this. This is, if we split this now into eighths, okay, so it's how many out of 8? I don't want this, and I don't want 3, so that's 3 eighths that I don't want. So that means the rest of them, which there's 5 of them, would be not a 2 or a 3. Letter D, which is more likely, spinning a green or spinning a 2? So look how much space the 2 is, look how much space the green is. Which one is more likely? There's more space on spinning a green, so that's more likely. How about more unlikely? Spinning a 1 or spinning a blue? That is just the opposite. Now we want the smaller one, which is spinning a 1. So here's examples. You have 20 emails in your mail inbox. 13 of them are junk. So what's the probability of junk email? Well, there's 13 out of 20. There's our probability. What's the probability of a perfect vase? At a vase factory, 4 out of every vase, 20 vases are chipped. I want a perfect one. Well, if 4 are chipped, that means 16 are perfect out of 20. You flip a coin 5 times. It comes up heads 4 times. So what's the theoretical probability of heads? What could actually happen? Well, there's 1 heads out of 2 sides. So the theoretical probability is 1/2. But our experimental probability is different. Here we came up heads 4 times out of our 5. They do not match. They don't have to match. How about if you roll a dice 50 times? So we know that our bottom number is going to be 50. What's the theoretical and the experimental probability of rolling a 5? Well, if you look at our table, here's 5, or graph, I should say. I rolled a 5 8 times. Well, we have 6 sides for theoretical. I'll move it up here. 6 sides for theoretical, and there's only 1 5. So our theoretical probability is 1/6. Our experimental probability is 8/50. Theoretical and experimental probabilities are not equal. They will not be the same. However, the next one is a big one. To make the experimental probability closer to the theoretical probability, we have to repeat the experiment more times. The more times you do it, the closer to theoretical you're going to get. Last lesson is a really short one. This is geometric probability. This is probability based on space, okay? The area, basically, of the shape or whatever it is. And usually it's a shaded versus non-shaded. So the probability is the area of the given area, so like the shaded or the not shaded, over the total area. So if we look at example A, I want to know the probability of the shaded region and the probability of the white region. Well, they're all the same size, so we don't have to worry about it. We have 2 that are shaded, so that's 2 out of, we have 6 spots. And non-shaded or the white regions are 4 out of 6. Try letter B quick and then come back. Again, we have 4 equal spaces. So our bottom numbers is going to be 4 for both of them. The shaded region, there's 2. The white region is also 2. So again, if we simplify, we get half of that is shaded, half of that is not. So next class, you're going to be working on some probability stations. So if you need to go back and review this lesson before you do the stations, that would be great. If you have questions, send me a message. Have a great day.